So now in this video, we're going to come back to the 10 watt 5 ohm resistor, just cover it a little more. So imagine this is a quarter watt resistor. If this was also 5 ohms, it is not. But if it was 5 ohms, it could not handle near as much current as this large one right there. It would get too hot because all that heat's contained into a small package. We have a fairly large component right here. A lot of surface area to dissipate the heat. So the wattage, the amount of voltage and current, there's a linear relationship because it's a resistor. As you increase the voltage, the current goes up, so it gets hot really quick. But in any case, we got the 10 watt 5 ohm. I already showed in the last video, if you got 5 volts across 5 ohms, you're going to get about 1 amp of current. So we'll look at that again. And as soon as I connect that, I'm going to let go of the resistor because it gets pretty hot. So yeah, there we got, about 1 amp right there. 5 volts divided by 5 ohms equals 1 amp. Now, what we're going to do, let's say 1 amp, that's, 5 watts. 5 volts times 1 amp is 5 watts. It's a 10 watt component. You should still stay about halfway below that to prevent it from overheating. So what we're going to do to buy me some time, I'm just going to turn the power supply off. We can grab another 5 ohm, in this case 10 watt resistor right there. And it doesn't matter which side I clip, but now we're going to connect them in parallel. We're going to put 5 volts across both of them, and just wherever they connect. Doesn't matter. The metal doesn't have basically any resistance. It does have like a tiny bit, but compared to 5 ohms, it's practically none. We'll have a little extra resistance where the alligator clips are clipping. But yeah, now we have 2 of them in parallel. So right now, the power supply, we'll turn it on. It's still outputting 5 volts, but there you can see we got pretty much 2 amps of current right there. The current is being split up though, so it's 10 watts total, which is the maximum that each of these are rated for. But half the current's going through one, half the current's going through the other. They both got 5 volts across them. So each one of them has 5 volts times 1 amp of current, 5 watts going through them. And so they're getting much less hot than if we used a 2.5 ohm resistor that is a 10 watt, a single one. Hopefully that makes sense. Putting them in parallel. We can keep adding them in parallel and we'll be able to get another amp of current without having to worry about overheating the resistors. So anything that's in series, as long as 5 volts is maintained across them, so you would need to take into account whatever other voltage other stuff is using. You'd have to add that to the power supply. But as long as you keep 5 volts across the resistor, they're going to let 1 amp of current go through them each because they are 5 ohms. So that's 2 resistors. I made a couple of these. These are 10 ohm resistors that are 10 watts. So they're the same size. I'm going to try not to touch the component. There you can see, same size. So that's where the wattage comes in, the surface area on it, and to an extent the material it's made out of, but mostly it's the size. Some material dissipates heat more than others. That was not the resistor I thought it was. It's still a bit warm. So yeah, there's a 10 ohm resistor. So again, we can put 5 volts across it. It's going to have half the current of one of those 5 ohm resistors right there. And so since there's less current, there's going to be 5 volts across it, but less current. So now we have, what was that again? About probably 2.5 watts right now of power going through there, but we got less current, So I made this, since that was half a watt, I must have made this so that, well, at 5 volts, we can get right there. We can get about 2 amps of current right there. So we got the same effect right here that we had when we took, these should be, nope, they're still pretty hot. The 2 5 ohms in parallel. These have twice the resistance each. So now I got 4 in parallel. Parallel means you got all of one end connected together. That feels a little warm too. And all the other. The wires are also going to help dissipate heat. They are, you know, bundled together though, so they're not going to dissipate heat as well as if I spaced them out. So that's why I'm keeping things kind of lower down there. But yeah, we can, you know, add them in parallel right there to get more current going through them, but ultimately they will split up the current. As long as they are equal value resistors, they'll split up the heat generated equally. So we technically, you know, if we had more air space between these, would have basically a 40 watt resistor when you combine these four together. Their wattages would add up, but since they're kind of bundled together, they're not dissipating heat as good as they could, and so they will get quite warm. Also, you know, you can add, I'm just going to grab these now. Yeah, they're not terribly warm anymore. We can add these two in series. So first, I'm going to just attach the power supply. So 5 volts, we'll get about 1 amp of current going through there. And now, what I'm going to do is keep this one clipped there. We can also add this in series there. So this is also, yep, 5 ohm right there. It doesn't matter which way we put them. So I'm going to hold these two wires so they are touching each other. And now we'll get half the current right there. And they're both going to get half as hot right now. Less than half as hot. Because they both have half the voltage across them. It's dividing the voltage, basic voltage divider stuff. And half the current. So I think that would be 1/4 of the wattage. You can combine these resistors as needed. So I generally have no plans to get higher wattage resistors. If I need more current, usually when it comes to higher wattage, it's because you're dealing with higher current. But also if you're using high voltage, that will increase the wattage too. So we do still have, you know, limits. But for these components here, generally to get more current, I'm just going to put more of them in parallel. And if need be, I may also do some, you know, series connections. These are different value resistors. But now we have like a 15 ohm resistor right there. And this resistor will get hotter. It will have more of the voltage across it the way that it divides. But we won't go into that. That's basic electronic stuff. But whether it's small scale, which is where you usually learn the basics, or a larger scale like this, the fundamentals are the same. Just the higher power you get, the lot more damage you can do. So you got to be careful. Make sure you are doing good. And so when it comes to the, I don't know why I made a second one. Maybe so I could double the current, what I got there for something. But yeah, I have these barrel plugs right there. And so the, I think it is center positive, I believe. So I believe that that positive right there goes to that pin in the middle. And I believe this is a negative right there. We could do a continuity test where if you touch that point there with the multimeter probe and that one, if the multimeter is set to conductivity, then it will beep. It'll tell you there's a connection there. But in case, yeah, I got the barrel plugs there. And with the power banks, we can look at the front. I can plug the barrel plug into there. And then I can plug like a charger or something, depending on whether it's going in or out. But yeah, I can plug something else with another barrel plug there. You just screw down the wires. Pretty convenient right there. So, in any case, again, this is not exciting stuff, but very important to understand while you're building circuits. I briefly mentioned these topics while I'm building circuits using these components right there. But when you're trying to learn everything else I'm talking about in the video, plus like the basics with using these, I kind of rushed through the basics of connecting these in parallel and stuff. So I figured I would do a longer video. It's still useful if you're watching the more complex videos. In those videos, you'll just get a reminder of connecting these in parallel to get more voltage. Because it doesn't matter how many, or more current, I mean, doesn't matter how many you connect in parallel, they will all have the same voltage across them. And as you keep adding in parallel, as long as the power supply can provide that much current, each one's just going to let current go through it based on the voltage across it. So the voltage won't stay the same unless you try to draw more current than it can handle or that you set for a limit. So again, long video. I'm assuming most people will find it boring, but hopefully you enjoyed. Thanks for watching. Make sure you check out one of the other videos I'm posting on the screen and check out the links down below. They all help out a lot. I'll see you in the next video.